Number systems. Finally, we are bearing it. We are bearing this chapter. I'm very excited. It's the last part that we do with the what? With the number systems. What is it? We are going to be doing the same binary arithmetic. The same binary arithmetic. Okay? Binary math. Actually, this is the same as arithmetic means math. Ne? This is the same binary math. What I'm going to do there, we are going to basically what? Do the same subtraction. Now we are going to do subtraction, the special form of subtraction where we are going to what? Put sign bits. Now we are going to use sign bits. Now our sign bits, let's identify them first. We use a 0. We put an asterisk. Remember, in a certain database, ne? If it is a bus for numbers, a specific line will be, let's say bit number 7 or bit number 8, whatever, will be assigned as a what? As a sign bit. Just like we'll have a carry flag and whatever, all of them are what? They've got designated area spaces that are what? Are assigned to them. Now, so we assign a 0 to mean positive, and we assign a 1 to mean negative. Okay, now this is positive, that one is what? Negative. Okay, positive and negative. So what we mean here is, let's say we have a number. Let's say we want to work with two numbers. 101, comma 101. Let's say that number there is supposed to subtract another, which will be 1 0 1 0 1 1 1 1 2 3 4 5 6 7 1 2 3 4 5 6 7. Is it a wise idea? Yes, it's fine. There's nothing. Then let's say comma 0 1 0 1. I'm making an example. I'm making I'm making very long numbers. What I can have lots of work to do, so what you can what hopefully following me through a lot of work will assist us in understanding all the intricacies of the work. So the first thing we do, we know that the top number, the positive number 1 0 1 2 3 0 1, comma 1 0 1. We have to first what? The first thing we do is align the commas 0 1 0 1, and then the rest is 1 1 1 0 1 0 1. So now we know that what we do next is what? Is probably, let's say we had another 1 here, just for clarity. We would have what? We know our next step is to make sure that we standardize the number of what? The number of bits. Okay, these, we have done nothing wrong. We put a 0 behind the number. We put a 0 after the number, after a comma. So obviously this is redundant. That is redundant. All that is doing it. However, it's very useful in this case, because if you don't balance up these numbers, you will struggle. So what you then do is, we are subtracting that number. Try and be slow, yeah. So that now, what does it mean? It means that we are abhorrent to the negative. So what we do, we start with 1's complement. We want to change that to a positive. Okay, what do we do? The number on top is positive, so our sign bit is going to be a 0. I'll again include the star, and the bottom number is negative, and we'll what? Include the star. Before our number, we normally assign what I will call buffer bits. These are buffer bits, so we put zeros before the what? The number. Okay, and then what we then do, we then write the what? The top number as it is. That will be what? That will be 1 1 0, 3 1s, 1 2 3, a 0, a 1, comma 1 0 1 0. Now we obviously have to do 1's complement of the bottom number, starting with the buffer itself. So what we do is, the buffer was a 0, that changes to a 1, and then what we do then is what? We change every 0 to a 1 is 1's complement, every 1 to a 0. That would be 1 0. This is 0. It's changed to a 1. 1, that will be 1, sorry, 0, 0, 1, 0, 1, 0, 0, 0, comma, 1, 0, 1, 0. Okay, so let's double check. 0, 1, 0, 1, 3 zeros, a 1, a 0, a 1, a 0, and a 1. So what you then do is, this was just me explaining. I don't need this box here. I don't need this box here. So what you then do is we add those two. 0 plus 0 is 0. That one there is 2. That's a 1. That's a 2, comma. That is, okay, 2. Then this is 2 again. That's a 1. That's a 1. That's a 2. That's a 2. That's a 2. Another 2. That's a 3. That's a 2. Now, yes, the sign bits are involved in the what? In the addition. It was not involved in the what? In the what? When we were complementing, we didn't complement the sign bits, but in the addition is involved. So that 1 plus 1 there, our sign bit is now positive, which makes sense because we're subtracting a smaller number. Our new number is going to be what? It's going to be positive, but it was a carry. This is carry. The rules don't change. When you've got a carry for the ones complement or the nines complement, you add that carry. So we come and we add that to the least significant digit, and we do our math. Now is going to be 1. Our answer is in binary. That's 0. That's 1. That's 0. We are adding. That's 0. That's a 1. That's a 1. And then 0, 0. How many zeros? 1, 2, 3, 4. 1, 2, 3, 4, 3, 4. And that's a 1. And what does it say here? It's a positive number. So my answer is that much. All right, let's try and see if we are right. Let's come and do it directly here. We'll say 2 minus that. That's a 1. Okay, we borrowed from there. Now we come and borrow from here. That's a 1, 1. That is one set of 2. So that is 2 minus what? No, well, look, we actually borrowed here first. So when you go there, we have actually taken a 1 from there. 2 minus, what did I do? What did I do? What did I do? What did I do? I am getting tired today, I'm sure. Once we took this was 2 minus 1 is 1. 0 minus 0, I somehow, so that is a 1. This is where I'm supposed to borrow. From there, I borrow there. This leaves us with a 0. That's a 1. Now, 0 minus 0 is a 0, comma. Now, that is 0. We need to borrow there. That is what? That is a, when you borrow a base, that's 2. 2 minus 1 is a 1. Then that there will be, we borrow from here. Once we borrow, okay, when we borrow there, it was a 0 left. Now when you borrow, it's a 2. 2 minus 1 is a 1. That is now 0 minus 0, which is 0. 1 minus, that is 0. That is 0. That is 0. And that's a 1. If you look at that answer there, it is 1 with 4 zeros, 1 with 4 zeros, 2 ones, 2 ones, a 0, a 0, 0, 1, 0, 1, 0, 1, 0, 1. But of course, this is me, the lecturer, explaining what's going on. Students may not do this part. This was just an explanation to show you that the two answers are actually coinciding. The two answers are actually the same. So this is the one example. I did a very long number here just to show you how the what. So remember, buffer your numbers from the sign bits. And remember, it does not matter from the sign bits. It does not matter how many buffers you put, okay, but you must put the same number of buffers from the sign bits. First step, you buffer your numbers from the sign bits. The second step, what you do, you obviously the all stuff of is still applicable, balancing up your digits and aligning your commas, that's still applicable. I'm now referring to stuff that is peculiar to this particular situation here. So you buffer your numbers from the sign bits. What you do, you complement negative numbers including buffer bits but excluding sign bit. You may not complement the sign bit. Okay, yes, we did complement the what, the buffer bit, but you don't complement the what, the sign bit. Okay, otherwise the rest of the rules follow. Okay, so in addition, when you're adding, the addition includes addition process. Addition, however, includes the sign bits. Okay, just remember this, very important. These are the key things that you need to remember. I'll do probably another example. Let me open a new page and say probably let me open a new page and do maybe 2 examples. I'll say, okay, let's probably say we're doing 1 0 1 1 0 comma 1 1. Okay, base 2 minus 1 0 1 0 1 0 1 0 1 comma 0 1 1. Okay, I want to emphasize the what, I want to emphasize on the what, on the balancing of bits. So so I make sure that they are different all the time. So what we do here, we say our, I didn't, let me put another 1 here. 1 1 0 1 1 0 comma 1 1. Then the commas, first thing we do, align the commas. That's the bottom number is 0 1 1. So when I balance, that's going to be a 0 there. Now the rest is 1 0 1 0 and 1. We are actually supposed to subtract that number. So what do we know? We need to balance up the bits. Now let's see. This then says what? We are going to say this is our, we are abhorrent again to the what? To the negative. So we are going to say no. Let's do the what? Let's do the complement so that this is not negative, it's now positive. Okay. So what do we then do? We say okay, but remember now, I'm going to the old method. Remember now, we are doing what? We are doing actually sign bits. What we do here is we are going to say that there is what? Stays the same. 1 1 0 1 1 0 comma 1 1 0. We say we need a buffer for both. Start with that buffer, and then we say this is a positive number. We show that with the asterisk, and this is a negative number. We show with the asterisk. Now, what you then do is we say we complement everything. When you complement, we include the buffer bit. So what you're gonna do is this is gonna be a 1. Then we complement that number there. Once complement is going to be 1 0 1 0 1 1 0 1 0 1 0 1 0, comma, that one there is gonna be 1 0 0, and then you say we add this 0 plus 0 0 1 2, that is 1 0, and then this is 1, that is 2 again, 1 0, that will be 2 again, 1 0, 2 again, 1 0, 2 again, 1 0, and then this is 3 1 1, and it's 2 again, 1 0, and this includes the what, the addition includes the sign piece, so that will be 0, and then that will be what, our sign bit doesn't change position, our carry jumps over, because our last answer was 2. So what do? We then have to say, come back and say what? This is a carry, so the carry must be what? You add carry in the case of one's complement. Add carry. Okay? Therefore, we come and add it there. There is what? Our 1. Our 1. This is an answer in base 2. Our 1, our 0. Remember, we're adding, so we just add it there. The rest stays the same. 1, 0, 1, 2, 3, 4, 2, 3, 4, and then we have our 1, and it's a positive answer, so our answer is positive, and there is our answer. Okay, so I'm hoping this looks too similar to the other example. Let me just verify that I didn't do the same thing twice. No, I didn't, because it looks so similar to the previous answer. So what do we have now? We've checked this here, we borrow there, we borrow a set, that's 2 minus 1, that's 1. We need to borrow there a set. When you borrow a set, that's 2 minus 1 is a 1. Now this was a 0 left, 0 minus 0 is a 0, comma. Now we need to borrow here from there. This is 2 minus 1 is a 1, 0. When you borrow a 0 was left, 0 minus 0 is a 0, 0, 0, 0, and 1. So yes, if you look, these two numbers are identical, so we are 100% correct. I don't want to see that as an educator. This is just me showing you that the answers are the same, but I still insist that you may not do it, because it looks like what? It looks like cheating. This is me showing you that what you just done here actually works, alright? But when you're doing it, the process, you don't have to what? You don't have to do that. Now what I'll do is, if this works, it must work also in what? When you do the what? When you do the small number minus big number. So let's take the same numbers and say, okay, what if we said 1 0 1 0 1, comma 0 1 1, was the one subtracting 1 1, commas are aligned, 0, what is my 0 doing? 0 double 1, 0 double 1. First things first, balance up the numbers of digits. This is the negative number. What do? We don't like, we are going to complement the negative number. What do we have now? We have a scenario where we have the sign bit assigned is a 0 for the positive, the buffer, and then we have 1 0 1 0 1, comma 0 1 1, and then for the negative, our sign bit, our buffer would have been 0. We are complementing, so that's 1. This is the buffer bit being complemented to a 1. Then the rest of the number is 0 0 1. What am I doing? Doesn't look right. Something is missing here. 1 0 1 0 1 0. So, oh, I did not put a buffer, did I? I did not put a buffer. I thought I put a buffer, but I didn't. I'm noticing that this number is exactly that, so I did not put my buffers here. I talk about them, but I did not put them. So what I then have to do now is move this to accommodate the buffer. and move that as well. We move that. Okay, we'll move that. Probably I have to delete this. Okay, so I come and I say our buffer there is 0. Our buffer there was a 0, but we are complementing, so that it's complemented to a 1. Then the number is 0 0. The complement of the number is 1 double 0 and a 1 comma double 0 and 1. Then we add 1 plus 1 is 2. 1 plus 1 is 2. 1 plus 0 is 1. The comma stays. 1 plus 1 is 2. That's a 1. That's a 1. That's a 1. That's a 1. That's a 0. That's a 1. That's a 1. And we expect this 1. The bottom number is what is bigger. So we do not have a carry. No carry. What do? We know that our answer is negative, which we know already in this case. This is our negative. We know what do we do. However, remember when you complement, we don't complement the what? The number, the sign bit. So sign bit stays negative, but that becomes 0, 1, 1, 2, 3, 4, 1, comma. It's 1's complement. So this is our answer. So now, if you look at this here, 1 with 4 zeros, 1 with 4 zeros, a 1, 0, 1, 1, and this is basically what we have there. This is the same as that, except that is what is negative, and therefore it shows that our method is working. I don't want to drag this forever. What I'll do is I will show that it works with what? I will come back, I will go back to the top. I will go back to the top and say, alright, what if it was 2's complement? What if it was 2's complement? Probably before I do that, let me do this. Let me close that part and have a little bit more space. Okay. Let me say, what if I didn't do the part where this number was the what? Can I squeeze this a little bit? I think I made it too big. But let me say, okay, the reverse math. I'm reversing the math here. What are we doing here? I'm taking that one there, the bottom one. I'll try to make it small. The top one is 1, 1, 0, 3 ones, 1, 2, 3, 0, 1, comma, 1, 0, 1, 0. I'll take that part and move it up. I will move this up. Then I will say, previously I was subtracting the other one. Now I'm going to subtract this one here. So I'm going to say 0, 1, 0, 0, 1, 0, 1, 0. And then it's 1, 1, 1, 1. And then it's comma. The commas are in line. I'm happy. 0, 1, 0, 1. I'll say, okay, what if that one was subtracting the bigger number? Okay. We'll say, okay, the negative number, we are abhorrent to it. I'll keep saying this is negative. The positive number is positive. It stays as it is. 0, 1, 0, 1, 0, 3 ones, and then 0, 1, 0, 1. Okay, what did I do? I forgot to include my buffer. So I'll move this a little. Why is this making me suffer now? I want to. Okay, let me just have, I'll just have to redo it because it's obviously not helping to keep hitting a hole and getting nowhere. I'm supposed to, now I'll repeat this, put my buffer first, then my number 0, 1, 0, 1, 0, 0, 1, 0, 1, 0, triple 1, and 0, 1, 0, 1. And then the buffer here is going to be complemented to a 1, and then I'm going to have my other number complemented 0, 0, 1, 3 zeros, 0, 0, 0, 1, 0, comma, 0, 1, 0, 1. Okay, what do we want to do? We want to add, this is 2, that's a 1, that's a 2, that's a 1, comma, the commas are aligned, that's a 1, that's a 2, that's a 2, that's a 1, that's a 1, that's a 1, that's a 1, that's a 0, this is a 1. Now the sign bits are adding to give us 1, meaning our answer is negative. So what do we have? Again, it's a bigger number being separated from a smaller number, no carry. So what do? No carry means what? No carry means you have to what? Complement again, same complement, and your number is negative. You can see that we don't complement the what? We don't complement the sign bit, so the number stays negative, and then when you complement, one's complement is going to be 0. It's going to be 0, 1, 1, 2, 3, 4 zeros, 4 zeros, and then it's going to be 2 ones and a 0, comma, 0, 1, 0, 1. And this is obviously plus 2. Now if you are correct, it must be the same as this. Ignoring the first one, it's 1, 4 zeros, 1, 4 zeros, 2 ones, 2 ones, a 0, a 0, 0, 1, 0, 1, 0, 1, 0, 1. So our answer is the same, only it's negative, and we are happy. So this is how what? How we do the calculation using what? Using sign bits. I hope that was straightforward. What I'll do is I'll come back to this and revise this on the same space to show you that we now know 2's complement. So I'm going to do a revision on the same space. My tea is getting cold and it's very cold here. So now on the very same space, what we're going to do is we're going to come and say, if it was 2's complement, nothing changes here except that this one here would have added 1 there. So that would have been what? That would have been a 1 there. So we'll come and say, for 2's complement, this would have been a 1. Okay, if this was a 1, everything else, only thing is this will be 2's complement. Okay, so everything else is what? Is going to be, so now we don't, what do? This is no longer true for 2's complement. So what do? We do the addition. If it's a 1 there, that will also be a 1 when we add. Okay, that will be 0 plus 1 is 1. Now is 2, it's 1. You see the rest of it will stay the same. We will have a carry, but we will ignore the carry. With 2's complement, remember we only add a 1 once, either during converting to 2's complement or what? Or in 1's complement when we add the carry. So we do not add a carry in this case. We do not add a carry in this case. As you can see, our answer goes straight up because this came from adding a 1, but here we don't add a 1, the number came straight. It's like we are rewriting that number. So what I'm trying to point out here is, if as long as it's not 2's complement, the process is the same. There's no need for me to go through this and repeat what? The very same thing. If we came here and we're using 2's complement and the other number was negative, all that would have changed is that this is not 1's complement, this is actually 2's complement. That would be the only change here. And then obviously 1, 0 would have stayed as is. So this would not have been 0, 1, it would have been 1, 0. You remember with 2's complement, the number stays the same up to the first up to the first what? Up to the first, this will no longer be true. This part will no longer be true. Okay, so the number stays the same up to the first, from the right up to the first one. So now what you then do is you come and you say up to the first one, the rest is one's complement is fine. So when you add here, it's going to be 1, 1, that will be 1, that will then be 2. So that will be 1, 0 carry 1. From that point on, it's all the same. Of course, it's a smaller number trying to subtract a bigger number. The subtrahend is bigger, so you'll have no carry, so you'll have to complement again. But you'll have to do the same 2's complement. When you do 2's complement, that one will what? Up to that one, it will be the same, so everything else changes. You don't complement the what? You don't complement the sign bit, you complement the rest. That will be 0, 1, 2, 4, 2, 4. That's 4 zeros, that's 2 1s, and then there's a 0 comma, and then there I know I must leave the last one, goes from the right to the last one. It stays the same, so the 101 becomes 0 1 0, but that 1 is the one that would have stayed, and then this is the same as, if you look at this answer, it's actually the same as that. I already knew it was going to be correct. So that was a deposited tick there, because I knew it's going to be correct anyway. So all that changes is how you do the complement. The practice stays the same. If you go to the other page as well, I hope there's nothing that is releasing inside. Once I've done the 1's complement and the 2's complement, what I'm doing here is showing you how the sign bit comes into play. Alright, everything else is basically not that difficult. So we go to the second page also. We say, okay, in this page, what am I doing there? Alright, in this page here, we would have done the same math, except that this would have been 2's complement. And 2's complement, we said, no, that one would not have changed. That would have been the difference. Go through it. This one would not have changed. So, the rules are different for 2's complement. We do not add carries. We ignore carries. In 2's complement, we ignore carries. What then happens is that when we add there, our first digit would have been 1 already. Our first digit would have been a 1 already. So, the rest would have stayed the same. But this would have been ignore carry. Okay, with 2's complement, you ignore the carry. It's a bigger number subtracting a smaller number, so yes, there's a carry, but in the case of 2's complement, you ignore the carry. So you will see that your answer is positive because the 0 there. Your answer is positive. Yes, if you take out if you take out a smaller number from a bigger number, your answer will be positive. Now the same would have been done here. Would have said, if we're doing if we're doing 2's complement, 1 0 would have stayed as is, so the last part there would have been 1 0. This would have been 1 0. Okay, once this was 1 0, this can't have been true anymore. Okay, this can't have been true anymore. Now what will happen is that there you have when you add, that's a 1, that's 2, which is 0 carry 1, the rest is going to be the same. So what happens is, when you don't get a carry, you repeat the same complement, and that is 2's complement. So when you repeat the same complement, 2's complement, what then happens is that this one stays the same, the rest is, you do 1's complement 2. If you remember, 1 means negative, so your answer is still negative. No complement, no carry there. Only comes when you're subtracting a bigger number from a smaller number, and your answer is going to be negative. So this is so straightforward. Once you understand what you're doing, how to do the complements, the only change here is adding sign bits. So what I would suggest you do as homework is to go back to when you were doing to all the examples we did when I was teaching you the subtraction, but where I didn't use complements, where I didn't use sign bits. Go back there. Remember to add Remember to add your buffer region. Remember, your buffer region is going to be You can use more than two bits for the buffer, but when you complement, that part is complemented as well. Okay, what I want to do is, I hope it's not long, I want us to do an example where we are going to use two negative numbers. Let's have a scenario where we have two negative numbers. Let's say simple numbers. Let's say we're saying I will ask to compute minus 101 minus 111. Okay, in earnest, this is what? This is 5 plus 7, so our answer is supposed to be equivalent to 12. Let's see if this works. Minus 101 base 2 minus 111 base 2. This is a negative number. We abhor the negative. So what do? We complement this. We're going to use 1's complement. And then this is going to be, show that it's a what? It's a negative with a 1. We put a buffer. That buffer is going to be complemented as well. And then we repeat our number. It's complemented 0, 1, 0. We do the same here. It's a negative number. Okay. And then what do? We show that the buffer was a 0, it's complemented, and then the rest is 0, 0, 0. What do we then do? Was when you complement that, all the ones change to zeros. What do? We then add. That is going to give us 0. That is going to give us 1. That is going to give us what? That is going to give us 0 we're adding. That is going to give us 2. Now if this gives us 2, what happens? Then we've got 1 plus 1 plus 1 plus 1, it's what? 1. And then we add a carry. What do? We come and we add the carry. So when we add that, it becomes 1, 1, 0, 0. But our answer is what? Our answer had a carry. Now what do? The answer, the answer is, the final answer is what? Is negative. So what do we mean? Our answer is actually what? In 2's complement. So sorry, in 1's complement. We are doing 1's complement. So it's actually 1's complement, not 2's. This is in 1's complement. So when you then say complement again to get your original answer, you have this saying is negative. You never complement the same bit, and when you complement is 1, 1, 0, 0, and this is base 2. And of course, 5 and 7, negative 5 and negative 7 give us what? Negative 12. If you convert, this is 8 and this is 4. 8 plus 4 is 12. Let's do another number. Let's say we have 1, 0, 1, 1, which is 11, negative, subtracting 1, 1, 1, 1, which is 15. Okay, what do? The negative number 1, both of them are negative, minus 1, 1, 1, 1 base 2. All right, what do we then do? This is negative, assign. But then we are going to assign the buffer. Buffer was a 0. It's going to be converted to a 1 when you do the complement. Oh, I didn't show that I'm doing the complement here. Negative numbers are complemented. Okay, so I didn't show. Oh, what am I doing with an arrow? Okay, I need to show that I'm doing the complement there as well. Right. So what is happening now is that this is the buffer is changed to a 1. Then this is what? 0, 1, 0, 1, 0, 0. That one there is also negative, so it's complemented. So what do you have? Negative. There was a buffer. It was a 0, it's changed to a 1, and then the rest is what? Complemented. Okay, the buffer was complemented from a 0 to a 1. So what do? We then add. Okay, this is going to be 0. This is going to be what? This is going to be 0 again. This is going to be 1. This is going to be 0. This is going to be 2. Yes, we can add with the what? With the sign bit. So this is going to be 3, but our sign bit doesn't change position. So this here is our carry. We are doing 1's complement. What do? We add the carry. I didn't say add carry this side. I just said it, but I didn't indicate it. Add carry. So we add the carry. So we add a carry there, and our final answer is what? That is 1 0 1 0 0. That will be 1, meaning it's a negative. What does it mean when it's a negative? It means the answer is actually in what? In the ones complement format. What do? You complement again. I didn't indicate that I'm complementing again. Yeah, I'm getting tired. I'm complement again. So that means we don't complement the sign bit, so it remains negative. So but this becomes 1 1 0 1 0. Now if you look at this is 11 plus 15. You expect your answer to be what? To be 26. If you look at this is base 2, so this is here. This is a 16. A 16 plus 8 is 24. 28 plus what? 24 plus 2 is 26, and therefore you can see it works very perfectly. Had you been asked to do the same thing with the what? With the 2's complement, I don't see what the problem is here. You simply change. You see, this is very smart. So all you do is what? Remember the buffer. Remember when you complement, the buffer is included in the complementing. Remember that you do not complement the what? The sign bit, but the sign bit is involved in the addition. Those are the things that you have to look out for, right? If you're asked to do this same thing with 2's complement, would have said, let's say 2's complement here 1. Okay, I'll say minus. I'll just do the 1. I'll just do the 1 because I expect you to be, for your homework, to be able to do the other one. So let's say it's minus 1 1 1, and this is base 2, and you're supposed to do 2's complement. And then probably I'll take it slower this time just for everyone to catch up. I'm a little bit tired today. This is a negative. This is a what? A 0. This is a what? This is a, let me probably just represent for now and not complement yet. I want to take it in steps for everyone else to follow. I'm just rewriting the number as it is. So all I'm doing is putting a buffer, and then I'm putting 1 0 1. I'm saying this is also negative, and I'm putting my buffer, and I'm saying this is 1 1 1. I'm saying okay, all negative numbers are going to be complemented. I'm using 2's complement. All negative numbers are going to be complemented. So you never complement the sign bit, but you can complement the rest. This is 1 0 1 1 0 1, but the last one and the rest of the number do not change. So there's nothing, there's no zeros, so we end there. We come here, we say that one stays, we don't complement it. That one there is 1. The buffer is complemented. This is 1 0 0 0 0, but the last one is not complemented, and the rest. So then we add this, and then you say this is 2, this is 2, and this is what? This is 1, and then this is 2. But then we can add our what? Our sign bit is going to be 1 because it's 3. Does not change position. Our carry is this one here. This is 2's complement. What do? You ignore the carry. Okay, so our answer is equal to 1 0 0. This is not our answer really. This is the 2's complement version of the answer. So what do? You do 2's complement again to get your actual answer, and our answer is equal to that 2's complement. Our answer is equal to negative. That means negative, and you complement that 2's complement, it's 1. The first one and the rest of the number stays the same in 2's complement, and there is our answer. And I think this was very clear. Now I'm expecting that you repeat this part here using what? Using 2's complement, so that you can see. All I'm trying to do here is I'm trying to show you this is a little bit complex maybe for some people. I hope that they were able to understand. Therefore I've been doing this for a while now. I'm a little tired, so hopefully we were together and no one got lost. See you in the next chapter, because we are done now with what? We are done now with the number systems. Thank you so much. I hope you enjoyed.